In this video, I will show you how to solve a variety of trig-based equations, including some equations that will involve double angle expressions such as cosine 2x. Okay, but let's start with number 76. Well, this will be straightforward because all we need to do is get sine x by itself. So we would simply subtract radical 3 from both sides. So that's going to give us 2 sine x is equal to negative radical 3. Then we will divide both sides by 2. So that's going to give us sine x is equal to negative radical 3 over 2. Then you ask yourself, what is the reference angle? All right, ignore the negative sign for a minute. The sine of what angle is radical 3 over 2? So we've memorized these. So we know that the sine of pi over 3 is radical 3 over 2. So the reference angle is pi over 3. Okay, but we need to consider what quadrants we're in before we say the actual values of x. So the reference angle is pi over 3, but sine is negative in quadrants 3 and 4. So you should not have to draw this picture at this point, but I'm going to draw it just so you can see inside my mind. Okay, so these are the reference angles of pi over 3. Now, because sine is negative in the third and fourth quadrant, then these are the two angles that we need to name. So this is 3 pi over 3, 4 pi over 3, 5 pi over 3. So 4 pi over 3 and 5 pi over 3. Looking at number 77, the big thing you have to be careful not to do is you can never divide by a trig function. It's tempting to go like this and divide both sides by cosine x and cancel these out. But that is highly illegal. You cannot divide by 0. And that's really what you're doing because cosine of x is often 0. So if you divide by cosine x, you're dividing by 0. Instead, you need to get everything on one side of the equation by subtracting. So, for example, I could subtract cosine x tangent x from both sides. I'm trying to decide which way I want to do it. I guess it doesn't really matter. I could subtract cosine x tangent x from both sides. Okay, so that would give me the original cosine x that's right there minus the cosine x tangent x that I just subtracted. And this will be equal to 0. Now, that factor that I was tempted to cancel out will now become the GCF. So I need to bring that out. So I need to bring out cosine x. And that will leave behind 1 minus tangent x. All right, so using the zero product property, I can solve this equation by setting each part equal to 0. So I can set cosine x equal to 0, and I can set 1 minus tangent x equal to 0. Now, if I add tangent x to both sides, all right, that's going to give me 1 is equal to tangent x. All right, so these are the two expressions that I need to go ahead and solve. So, looking at the fact that cosine of x equals 0, what angle has a cosine of 0? Well, you know what, maybe I'll just draw it right here. Here's a little tiny unit circle. All right, cosine is an x value. So the x values are 0 here and here on the unit circle. So that's why I have pi over 2 and 3 pi over 2. Okay, now let's talk about where tangent is equal to 1. Well, that's actually something that we've memorized. The reference angle is pi over 4, all right? The tangent of pi over 4 is 1. All right, so fine. The reference angle is pi over 4. However, there's more than one answer, okay? Pi over 4 will certainly be one of the answers, okay? Here's pi over 4 right here. Pi over 4. Tangent is positive in the first quadrant, but tangent is also positive in the third quadrant. So what would be this angle, which has a reference angle of pi over 4? Well, over here at the left, pi is the same thing as 4 pi over 4. So this is 5 pi over 4. Okay, so those are the two additional answers. So I have pi over 4 and I have 5 pi over 4. All right, here comes that one with cosine 2x in it. The double angle identities for cosine 2x are very interesting because there's 3 of them. So you have to choose wisely whether which one you're going to do. So if I want a sine, I will use this one. If I want cosine, I'll use this one. If it doesn't matter, I'll use the top one. In this case, the other side of the equation has a cosine. So I might as well try to keep everything in cosine. So that's why I'm going to pick the middle one, 2 cosine squared minus 1. So that's why I'm going to write 2 cosine squared minus 1 is equal to cosine x. Let's get everything on one side by subtracting cosine x. So now I have 2 cosine squared x minus cosine x minus 1 is equal to 0. This looks like the type of thing that we factor. Start with 2 cosine squared. This will factor as 2 cosine x times cosine x. Skip over to the last term. The number 1 will only factor as 1 times 1. Inner plus outer must equal the middle. Inside, I have 1 cosine x. Outside, I have 2 cosine x. The middle is negative 1. So that means this has to be positive and this has to be negative to make negative 1. So that means that this is positive and this is negative. Also check that positive 1 times negative 1 is negative 1, and it is. All right, so fine, we have now factored it. So we will set each of the factors equal to 0. So if I take 2 cosine x plus 1, set that equal to 0, and then cosine x minus 1, set that equal to 0. This is going to give me cosine x is equal to negative 1/2. And this is going to give me cosine x is equal to 1. All right, ignore the negative sign for a second. The cosine of what angle is 1/2? All right, if you've memorized your stuff, you know that that is pi over 3. Okay, the cosine of pi over 3 is 1/2. So that tells me that the reference angle is pi over 3. Okay, so again, you should not have to draw the picture that I'm drawing. This is just for teaching purposes because you can't read my mind. I have to show you what I'm thinking. So these are a bunch of pi over 3s. The cosine in this case is negative though. cosine is an x value, it will be negative on the left-hand side. So that's why the two answers, the two solutions that I'm going to get so far are 2 pi over 3 and 4 pi over 3. Okay, now in addition to that, the cosine of what angle is 1? Well, that's going to be a quadrantal angle. Cosine is an x value, and the x value will be 1 right here at 0. That's the only place. So that's at 0 degrees. And by the way, sometimes we call this 0, sometimes we call it 2 pi. For when you're solving equations, we're going to consider this to be 0 and not 2 pi. So that's it for this problem. Okay, looking at this, let's just move everything to the left-hand side of the equation. So I'm going to subtract 5 sine x from both sides, and I'm going to add 3 to both sides. That's going to give me negative 2 sine x minus 1 is equal to 0. Okay, so now I just need to get sine x by itself. So I'm actually going to move this back to the other side. In retrospect, I probably should have just added 4 to both sides. But anyway, if I add 1 to both sides, that will give me negative 2 sine x is equal to 1. If I divide both sides by negative 2, that's going to give me sine x is equal to negative 1/2. So it's time to ask myself what the reference angle is. The sine of what angle is 1/2? Well, that's pi over 6. But we want negative 1/2. So where is the sine function negative? Okay, so we know that the sine function is negative in the third quadrant and in the fourth quadrant. Okay. The reference angle is pi over 6. So in the back of my mind, I'm thinking that pi is the same thing as 6 pi over 6. So that helps me know that this next one is going to be 7 pi over 6. Okay, and if I double this, that would be 12 pi over 6, which helps me know that just before that is 11 pi over 6. So that's it for number 79. Okay, let's do one more on this video. Okay, so let's get everything on one side. So I'm just going to subtract this from both sides. So that's going to give me 2 sine x cosine x minus radical 3 cosine x is equal to 0. You know what? I'm noticing that this is the formula for sine 2x, right? Where's that guy? Yeah, sine 2x, that's 2 sine cosine. And here I have 2 sine cosine. So someone was extra nice to you by giving it to you already in this form. But they just as easily could have started the equation with sine 2x. All right, so we could have had, let me get this out of my way. The original equation could have been sine 2x is equal to radical 3 cosine x. So then your first step would be to convert it to this. All right, and then we'll go from there. But I just wanted you to get comfortable with that. Anyway, back to solving. I'm noticing that we have a GCF. Do you notice that we did not divide by the cosine? Never ever divide by a trig function because you're dividing by 0. Instead, subtract it and then do the GCF. So cosine x is my GCF. So that will leave behind 2 sine x minus radical 3. All right, I just took away the cosines. So now, using the zero product property, I will set each of these factors equal to 0. So I will set cosine x equal to 0 and 2 sine x minus radical 3 equal to 0. So this is going to give me sine x is equal to radical 3 over 2. I added radical 3 and divided by 2. So where is cosine 0? Cosine is an x value. So x values will be 0 here and here. That's why x is pi over 2 and 3 pi over 2. Now, the sine of what angle is radical 3 over 2? Well, that is pi over 3. All right, we've memorized that. The reference angle. All right, the sine of pi over 3 is radical 3 over 2. Okay, but there's more than one answer here. Sine is positive in the first quadrant and in the second quadrant. So in the first quadrant, that is in fact pi over 3. But in the second quadrant, that is 2 pi over 3. All right, so that is it for number 80. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.